This is Io, the most volcanically active body in the solar system. In fact, you could say that Io is one giant volcano. It's covered with thousands of active volcanoes that have been spewing lava for billions of years. And yet somehow its lava flows never seem to run out. So what's fueling all these volcanoes? You see, Io orbits the planet Jupiter, and the gravity from Jupiter's mass is actually pulling Io apart. The stress from that constant tugging has created a bunch of internal heat inside Io, and that heat, along with some radioactive elements beneath the surface, creates an environment where magma can bubble up and erupt onto the surface as lava. And some of these eruptions are literally hundreds of kilometers high. But if you were standing on Io watching these eruptions, you might notice something strange. All of the lava seems to come from the same place. There aren't different vents like you'd see at Earth's Yellowstone National Park. No, it's all coming from one giant vent in the middle of Io, and this strange behavior gives us clues about what's really going on beneath Io's surface. Now, we know that Io has a core, a mantle, and a crust, just like Earth, and like Earth, Io probably had a molten core early in its history. That would have happened because when Io formed, it was very hot. Gravity caused it to collapse in on itself, and also because it was tidally stretched by Jupiter's gravity, this would have generated a lot of heat. But over time, the core should have started to cool off. So here's the mystery. If the core is cold, why is the magma still coming up from the middle of Io? We think the answer is that Io doesn't have a solid core. Instead, it's a liquid ocean covered by a thin crust, and here's how we figured that out. In 2009, NASA's Galileo spacecraft discovered that Io's magnetic field was totally messed up, and by that I mean it doesn't have one. Normally, if a planet or a moon is big enough, its spinning would create a magnetic field that extends outward into space, which is cool, because then we can measure that magnetic field and learn things about what's going on the inside. Like, for example, we know that Earth has a liquid outer core because its magnetic field lines perfectly trace the path of our planet's rotation. But the magnetic field lines on Io looked more like a crumpled piece of paper. And that could only mean one thing. Its interior must be completely chaotic, meaning that it couldn't have a regular magnetic field. And there's only one way that Io's insides could be that chaotic. Its core would have to be a churning liquid of iron sulfide. This discovery suggested that the interior of Io is a global magma ocean, tens of kilometers deep. Now, we didn't expect to find a magma ocean on a moon that far away from the sun. But according to our computer models, Jupiter's gravity does a number on Io. Even though Io isn't very big, Jupiter's gravity pulls it apart by about 100 meters every year. And that tidal flexing creates so much friction inside Io that it keeps its core in a molten state. And this means that there will always be fresh material flowing from the core to the surface, giving rise to new lava eruptions. And even better, scientists were able to use the Galileo data to estimate how fast Io's core is spinning. And it turns out that the core rotates faster than Io itself, like a figure skater pulling their arms in to spin faster. That extra spin creates even more heat, which makes the magma ocean churn even more vigorously. And it also generates powerful electric currents. In fact, Io's entire outer layer is a giant battery. Electric currents flow from the dark side of Io to the light side. That's because on the dark side, the intense pressure at the bottom of the magma ocean generates a bunch of electrons. These negatively charged particles then flow through Io's crust toward the positively charged light side. And since the crust isn't a perfect conductor of electricity, the electrons build up on the dark side, creating a negative charge. Meanwhile, the electrons leaving Io's surface leave behind positive ions, making the light side positively charged. So you get this electric circuit powered by your core. The problem is that Io's crust isn't great at conducting electricity. So, as the electrons flow through the crust, they cause little avalanches of rock. These avalanches make the surface of Io really rough, which is part of why it looks like this. But they also generate even more heat, and we think this heat, along with the heat from the tidal flexing, powers the giant volcanoes on Io. Of course, the energy comes from Jupiter in the first place. It's constantly stretching Io, which causes all of these crazy electrical and geological phenomena. And it turns out that the reason we do and see multiple spots on Io's surface where magma erupts is actually a consequence of this energy transfer. See, the energy from Jupiter isn't evenly distributed around Io, it's concentrated on the sides. On the top and bottom, Jupiter's gravity is mostly pulling Io inward. But on the sides, that gravity is literally pulling the moon apart. And this means that there's the most tidal flexing and electrical avalanches and heat on the sides of Io, and it's specifically on the side that faces away from Jupiter. You see, electric circuits need a complete loop to work, and the path along Io's trailing side provides the best connection between the negatively charged leading side and the positively charged front side. So, while Jupiter is powering the giant magma ocean inside Io, it's the trailing side of Io that decides where that power gets released. It's like if Earth's core suddenly started generating electric currents due to the tidal flexing from the moon, except instead of powering a few volcanoes on Earth, it would power one giant volcano that stretches across half the planet. And that's why all of Io's eruptions seem to come from the same place, because that's the only place that the electrical circuit connecting its battery is exposed at the surface. And while we think we've solved the mystery of how Io's eruptions are sustained, there are even more mysteries surrounding the makeup of Io's interior. For example, we don't know exactly what's in Io's mantle, and we're not sure if it has a solid inner core. And that's because we haven't gotten very good data from the interior. There's just a lot of heat. But someday, if we can drill down through the chaos below Io's surface, we might find answers to these questions. Of course, we would need some crazy drilling technology, like a drill bit that works underwater and a whole other drill bit that works inside a magma ocean. But hey, maybe one day. In the meantime, though, scientists are planning to use data from NASA's Juno spacecraft to create detailed models of Io's interior. So watch this space. And if you want to learn more about our solar system and the wonders of science, you can subscribe to the channel.